Good afternoon, everyone, and thank you very much for the opportunity to present to you the Northcote Aquatic and Recreation Centre as part of an international case study addressing the climate emergency solution that we've addressed with this particular project. What we're going to do this afternoon is run you through the process that we've done to date on the project, and at this stage, where the project's at the moment is that we're just about to go out to tender. We've been working on the design and documentation for approximately 18 months and started in August 2019. So one of the critical issues for the Darebin City Council, which was the local government authority that we undertook this project for, was that they were one of the first Australian councils to declare a climate emergency. And what that meant was that they were really seeing themselves as a key player in that market, and that they wanted to identify how they were going to position themselves within the industry. So the project ambitions were to provide a design that contributed in a significant manner to the municipality and acted as a generator for positive and sustainable change in Northcote. It was also to incorporate industry-leading environmental sustainable design principles where economically feasible, and to minimise the use of resources and energy in both construction and operation. And as part of the 9 key directions that they identified, this was part of their climate emergency plan, to create that mobilisation and leadership to address energy efficiency, renewable energy and fuel switching, moving away from fossil fuels towards renewable energy sources, zero emissions transportation, consumption and waste minimisation, fossil fuel divestment, so moving away from gas once again, adaptation and resilience, so looking at climate adaptation and how the building needed to address change, engaging the community, and then creating an action group so that there were clear, definable sort of outcomes. So as a design team, this meant that we had to avoid and reduce energy as far as possible, increase energy efficiency as much as possible, generate as much renewable energy on site as possible, buy renewable energy or buy energy from renewable sources in the future, and draw down existing emissions from past activities. And then, as a last resort, consider offsetting any emissions that can't be eliminated in the short term. So the existing site sits approximately 10 kilometres northeast of the CBD of the Melbourne metropolitan area. The existing building was completed in 1969 and then refurbished again in 1991. And you can see from the image on the screen that there's an outdoor 50-metre pool, there's a learn to swim pool, a toddler's pool, and then there's an indoor leisure pool, gymnasium, entry, and that it sits within quite a nice sort of park precinct, which is fantastic. The Woiwurrung people of the Kulin Nations are the traditional owners of the area known as the City of Darebin. And we've really sought to engage with the local elders to understand where the land and how the land was used. It was effectively migratory, sort of low grasslands and low woodlands between 3 major water sources. So it was a major communication route for the first peoples that inhabited the land. One of the things that we've had to address with the existing building is how we deal with demolition, and the work that we've done with the Green Building Council of Australia, and this was a test case, has identified a number of sort of options that sit in that kind of space. So what we've had to look at is a dismantling of the existing building and looking at reducing any sort of construction waste that goes to landfill from traditionally about 30% down to 10%, which has its own challenges. And we need to get the QS team on board to help us assess the cost implications of that process. The existing site has only ever been used as a recreational reserve, beyond how it was used as a low grasslands sort of mediatory or migratory space between water bodies, as I mentioned earlier. The site also has two large AFL and cricket ovals on it, tennis courts, and is in remarkable condition from a contamination point of view, which is fantastic. The site currently shares residents with local football club, local cricket clubs, the Clifton Street Childcare, and sits within a relatively dense residential area. So just to work our way through some of the planning in terms of the way that we address the building. The area in yellow in plan is really the entry of the building. So the idea was that we weren't touching the existing car park. There's 108 existing car parks on the site, and we didn't want to increase or decrease those. We didn't want to decrease it from a political point of view. We didn't want to increase it because we wanted to focus on green travel plans and sustainable transport options moving forward. So that really sort of crystallized the approach of getting the entry as close to the car park as we possibly could. The yellow area in the plan is actually all public space. So any person can walk off the street straight into the facility, feel part of the community facility without actually having to buy an entrance into the aquatic centre or into the health and wellbeing section or the gym space of the building. But you've got visibility and connection at all times through the whole facility. And that provides access to a public cafe, to allied health and to childcare facilities that sit within the facility. One of the key approaches we took to planning was that when you enter into the aquatic centre, you need to actually pass through the change facilities. And this is a very European kind of approach, but the reason that that's been done is that we want to encourage everyone that comes to this facility to actually wash before they enter the water bodies. And one of those critical factors through that process is that you are removing dirt and impurities from your body at that point, and that means that they don't go into the water, which means that you don't need to expend as much energy in the treatment of water, the heating of water, and the removal of waste elements from the water, which all lead to long-term energy and cost and operational savings over the life of the building. And we had a very clear thought process about keeping the wet bar, everything that included the swimming pool, so the program pool, the learn to swim pool, the zero depth internal leisure water, and the 25-metre pool, separate from the external environment, because there are 30-odd swimming carnivals that are held on site every year with local schools and local regional swim clubs using this facility extensively. We've designed it in such a way that the building can operate from a public point of view while still hosting those carnivals. And we've done that by separating some of the change facilities and segregating those so they can be used independently of the rest of the facility. This diagram talks to some of the massing arrangements of the building and speaks to the car park and integration with the green travel plan. Victoria Road has some extensive plans that are known as streets for people. So we're looking at a major change for major cycling routes to go onto Victoria Road, which is the north-south egress and main point of access to the facility. We also looked at an integrated landscape approach that took into account a lot of the existing foliage that was on the site and a lot of the existing tree infrastructure, and then was effectively supplementing that beyond that process. The basement was designed in such a way that it had a relationship directly to the larger volume water bodies, so the external 50-metre pool and the indoor 25-metre pool, and that cut down pipe runs and maximised efficiency when it came to the runs of pipes from plant rooms to those areas. An interesting point that we've discussed on a number of projects now is that for every change in direction that a pool hydraulics pipe makes, it costs roughly about $1,000. So any time that you can keep your runs of pipework in that space, it enables cost savings to be achieved. And you can see the massing and relationship of landscaping areas to Victoria Road from the main pool hall. So there's visibility into the pool hall, albeit that it is a halfway measure between the sustainability principles of limiting western light into the building, looking at glare and natural daylighting, and also views and relationships between internal spaces and external spaces, what we refer to as sport on display or sport on show. The structural approach that we took to the job was a very interesting one. It took into account a balance between minimising the carbon footprint of the facility. So we've gone for large span glulam structures interdispersed with highly efficient structural steel systems, and then a mixture of timber infill stud work to achieve the facade treatments, so that we've sort of balanced the emissions that are coming from the production of steel and aluminium in regards to facade, and Australia is very much in still in that vein. Its industries are set up more towards steel stud work and steel framing in buildings than it is towards timber. So it's a vectorization or a small movement towards where we want to see the future occurring as well. We've got concrete pool shells and large amounts of concrete structure to achieve the requirements from a technical point of view in terms of the pool shells and the performance of floors, as well as the in-ground conditions associated with piling. And you can see on the diagram the number of piles that sit underneath this building, and also the number of piles that sit underneath the pool shells themselves. So I guess one of the key questions that we raised as a design team was, is all electric possible? And really what this means is that we need an alignment between the local government authority and a strategy for climate action response that is agreed between the design team and between the client team to really sort of galvanise the response. And we had that with the City of Darebin. It's been a really productive and positive experience with the City of Darebin to date, and they've backed the approach. At times, we as a design team have been the ones to sort of pick up the baton and run with it and make sure that we're holding ourselves accountable to the claims and ambitions of the design and the project when it comes to our climate response. And we've done that by a focused removal of fossil fuels, so removing all gas. Traditionally, aquatic centres, and particularly aquatic centres in the Southern Hemisphere, have a high reliance on gas, particularly through those winter months when the demand for water heating and air temperature heating is at its highest, and daylight hours are at their lowest as well. Identifying renewable energy sources such as photovoltaics, and making provision for future technologies like the development of hydrogen as a renewable energy source into the future. And then accounting for seasonal changes in building performance and understanding the performance of the facility and its impact on customer experience. So for every degree of temperature change there is in the water, there are significant energy savings to be made. And so as a team, we've had to sort of balance the community expectation around warm water, and that's typically 28 degrees in Melbourne, and the requirements to actually heat that water and to maintain the heat of that. And also just to consider the whole of life cost and the building performance of those processes, because at 15 years, 20 years, 30 years, there's going to be a swapping out of mechanical technology or electrical technology. Battery storage is going to come down in cost. So how do we deal with some of those kind of elements and opportunities? Some of the other things that we needed to think about were what the energy demands of the facility were. So the startup loads for heating of water, the regulatory compliance for heating of water, our base energy requirements and our peak energy demand, understanding how that changes and fluctuates over the seasons, and then how beta load and public facilities gets smashed when it comes to the number of people that use these facilities. So how we actually treat and address that was incredibly important. And some of these figures here just talk to the sheer surface volume, or surface area and volume of water that are in these facilities, and the temperatures that we need to actually maintain. So they're quite significant in that regard. And then the amount of energy that's required to actually heat this water body from normal daytime temperatures up to that operating temperature, and how long it actually takes. So you can see that the outdoor 50-metre pool, as an example, takes 800 kilowatts and takes 60 hours to heat up to that time. And that's driven by regulatory standards as well. And then to maintain the operational loads of those facilities, as an example, the 50-metre pool external leisure water is that 250 kilowatts to maintain versus 800 kilowatts to start up. So what are the opportunities to really address performance and resilience, to understand the nuances of water and energy, and they are very symbiotic in their relationship, to understand the efficiencies of combined systems. So how does mechanical air treatment and pool water heating relate to each other? What are the synergies and efficiencies that can be achieved between those various elements? And then to supplement that, how can we engage? And local government's doing a fantastic job in that space of engaging with power purchasing agreements that are harnessing renewable energy resources and making a statement to the broader community to say these are solutions that can be achieved. So the strategies for reduction of energy usage are really about concentrating on building envelope and thermal performance, focusing on building ceiling. It's incredibly important from an aquatic centre point of view that these facilities are running 24 hours a day, 7 days a week, 365 days of the year. The internal ambient air temperature is 28 degrees. The water temperature typically is 28 degrees, slightly higher for some of those program pools and warm water pools. And as I spoke about before, if we approach things like pre-rinsing, we can reduce the demand for water treatment and create more efficient water strategies. So some of the inhibitors and barriers to this facility are really around how do we balance off the demands of facade versus carbon emissions? How do we deal with local procurement strategies and local industries that are not necessarily geared up for timber, as we've discussed previously? How do we make sure that we are not losing too much air out of this facility, and that we're really addressing that space in a positive fashion? And what are our strategies for capital expenditure versus operational expenditure, and where are the checks and balances effectively? The equipment that we run in these facilities is constantly evolving and changing. So we've had to look at electrical infrastructure, and really moving away from gas has actually increased our demand when it comes to substations and the demand on the grid. So there's costs associated with increased electrical demand. We've got heat pumps that are effectively filling in the gap between what we had done previously with gas boilers versus a larger number of electric heat pumps. There is acoustic aspects that we need to deal with in that space as well. And then there's the performance and tuning aspect of the whole facility. So understanding replacement costs, warranties, defects, liabilities, making sure that when this building is completed from a construction point of view, that we are assessing the project in a way that enables the building to perform at its optimal and designed intent. And that requires data and analysis of that data. And that this is very much an evolving aspect of practice, and one that, to be honest, really excites me, because the more data we have, the more knowledge we have about the way these buildings operate, the better we can design them and the more efficient we can design them. So this is really at the cutting edge of where we see the development of facilities going. Then there's the balance of how much money, or the finite amount of money that projects have when it comes to capital expenditure and the operational costs. So typically we work around 30% of a total project's cost over its entire life will be the capital expenditure to actually deliver and produce the building. And then 70% of the costs of the building are the operational costs. So any of those changes that we can make over that life are quite significant in that space. And we need to think about the half-life of these facilities as well. So when at what point we change the mechanical systems over, and technology is evolving so rapidly now that we need to make provision for that as well. Then it comes to compliance and certification. So we actually need to work with industry to understand where the certification and industry compliance requirements are. We need to engage with subcontractors and contractors, clients, and really treat the facilities management as more of a continuation of the development and design of these facilities. So it means constant communication with facilities managers, operators, client design teams, and contractors over the life of the building. And into the future, we maybe need to consider service agreements as to how we can manage and control costs and ensure efficiency in the operation of these facilities. Then we have the life expectancy of these facilities. So the design life of the Northcote Aquatic Centre is 50 years, where we need to plan at the inception of the project for its end of life and how the building can be recycled. And that may not be this design team that deals with that, but we do need to make consideration for how we repurpose, recycle, and reuse the facility when it actually comes to its end of life. So I won't deal with these elements in too much detail because I realise my time's rapidly running out. But the focus from an ESD and sustainability point of view has really been to focus on the energy sources, natural daylighting and customer experience, reduction of consumption, and maximisation of energy directly from the building, and then utilising the right materials and the right systems and processes to make sure that the operation of the facility works as efficiently as it possibly can, reduces demand from an energy point of view, but doesn't compromise on customer experience. As I said earlier, we'd worked with the GBCA to integrate this project into a six-star Green Star process. And this is just a table. You won't be able to read any of the content in there at all in terms of the roadmap for success, but there are categories across the entire project and responsibilities assigned to those categories of how we achieve that the number of points that are required to achieve a 6-star rating, and we are definitely on track to achieve that. And as a result of that, we're really in a position to actually deliver Australia's, or one of Australia's first best practice aquatic facilities, addressing whole of life carbon, air tightness, daylighting, green travel plans in terms of bicycle parking and electrical infrastructure for EVs, Indigenous engagement and shared knowledge, using low impact refrigerants, looking at climate adaptation plans and how this building will respond over its design life to the climate as it changes and evolves, utilising landscaping to maximise customer experience, sequestering carbon by using more timber structure, identifying various strategies in regards to water and air quality, and achieving an outcome that will hopefully provide an instigator to the community to deliver outcomes that will be able to be achieved on future facilities into the future. So I really appreciate everyone's time. Thank you. This is the proposed facility on the site as it's intended. We're very excited about delivering this project, and we think it'll be a significant change in the industry in Victoria and in Australia. And the project's even achieved interest from Germany in regards to efficiencies and processes and systems. So we're keen to talk about this project further and to build on the experience that we've been able to achieve today with the City of Darebin, and we really thank them and appreciate their leadership in this project. So thank you.
So I believe we have Brett Diprose on the line now. Kia ora, Brett. Thank you for your presentation. We've got a couple of quick questions from the floor here for you. One here from Marty. Most such pool/gym complexes in New Zealand use glulam portals. Why was steel used on the project if it was to address the climate emergency?
Yeah, good question. There's a number of points. Sorry, I was hearing an echo of myself. Really, the large span structures we've gone with have been the glulam structures. They're the ones that provide the greatest reduction in steel. We've used steel in the smaller spans. Australia is quite juvenile when it comes to its timber industry, and we don't have the volume of material that New Zealand has at this stage. So this project is a step in the right direction, but it needs to be balanced with the current skill set of the industry in Australia, as well as the ambition as architects to get more timber into our buildings. So it's a bit of an evolving brief, to be honest.
Were there any low-hanging fruits in providing energy efficiencies, and were there any government subsidies that allowed you to improve the design or scope of the project? Low-hanging
fruit is always around natural daylighting and insulation and acoustics and those kind of benefits. So they're the ones that are very easy to achieve. Good bang for your buck. The good selection of roofing materials that enable high insulation values and high thermal performance to be achieved is pretty easy to achieve these days with the way the industry is set up. In terms of government subsidies, there were limited subsidies through the state government, but also through ARENA in Australia and other organisations. Unfortunately, we didn't actually meet a number of those criteria and were unsuccessful on a number of grounds when we went for that application. So it's probably something that we need to develop and work with clients to ensure that projects such as these that have such a significant community benefit are maybe attracting funding. So it's more a reflection on the political environment than anything else.
Here's one final one for you. I feel like this is a little curly. Do you think that heated pools will be a feature of a zero carbon future? Should we be relinquishing some of these amenities?
It's a very good question, and it's one that we grappled with on this project, and we grapple with on every indoor aquatic centre project, and it's got a lot to do with the outdoor pool as well, and the fact that people have expectations around how they use these spaces, and when temperatures, say, fluctuate by even as small as 2 degrees, say from 28 degrees down to 26 degrees, that people stop using them. So it's really that balance of wanting the community to embrace the implications of their decisions. So being willing to swim in colder water bodies versus the climate and energy requirements of these spaces. So I don't think we'll ever get to a point where they're removed, because politically there's an expectation in the communities in which we live that governments provide these kind of facilities. But the communication around expectation on water temperature and the subsequent energy and heating costs is something that does need further discussion and consideration.
Well, thank you for your presentation, and thank you for answering our questions. That is Brett Diprose. Please put your hands together from Warren and Mani.